Hello, everyone. Welcome to SEC212, a breakout session on AWS data protection using locks, keys, signatures, and certificates. My name is Param Sharma, and I'm a principal software engineer here at AWS PKI. And I have been with AWS for more than 8 years at this point, mainly working on Certificate Manager, Private Certificate Authority. You might have heard about those services. And I am here with my colleague and a dear friend, Jeremy.
Thanks, Param. I'm Jeremy Stieglitz, and I've been at AWS a little over 2 years as the principal product manager for our key management service, also called KMS. We designed this tour today to be fairly quick and high level. We want to take you through just a high-level view of how we think about locks, keys, certs, and SIGs. And hopefully, if we do our job right, we'll explain some of the sort of foundational patterns and repeatability that we try to achieve with those patterns at AWS. And at the end of these presentations, we'll try to map out into some more richer details on some of the stuff we highlight. And so there's references to more YouTubes, quite a lot of good content this week that we're going to be talking about in the category of locks and keys. And we'll look forward to your feedback. So our grand tour today really looks at keys and locks, and that's my section. And we'll take a look at some products that we deploy to help you build locks and keys, either client-side in your own applications, or taking advantage of what we call server-side encryption, which is embedded in every AWS service that touches customer data. We have sort of a requirement and a security rule that if a service touches customer data, it must support data protection. And along the way, we'll look at some of our managed services. I'll be talking about KMS and Cloud HSM, and Param will cover Private CA and AWS Signer. Let's get in there. So really at the highest level, why do we think you can get some benefits from data protection? What's in it for you? I think first and foremost is the most obvious one. If you lock and protect and sign data, you bring protection to your valuable data in the cloud. That could be intellectual property or secrets or customer lists, and it's the things you care about keeping under quote unquote lock and key. Of course, that data may affect you and your profitability and your business, and it likely affects the customers that you manage. And so you also need to protect them as you think about data protection. And we're mindful of that. When you have a breach, you lose customer goodwill, you lose customer, your brand goes down. And so the ability to give you that data protection is a way for you to protect yourself and protect the data that you have to manage in the cloud. Of course, if this was just about putting things in locks and keys and SIGs and certs, you wouldn't get any use out of it. And so we have to be mindful that this has to fit into the AWS way of operating. So we think about automation, we think about tying to CloudFormation, we think about tying to Control Tower, and tying into organizations, AWS organizations, and other services so that you can deploy protection, but stay agile and build more automation. You'll need visibility and control to understand what's occurring. And we've tried really hard to make our security services very verbose in what's happening. For example, in KMS, any action that you use on a cryptographic key is always reported in the CloudTrail. So every change, every call, every function, every time you touch that key, we are reporting that event into CloudTrail so that you can build analytics or visibility or audit and answer the question, how was this used in AWS? We also spent a lot of time thinking about ease of use. In the context of locks and keys, we have a requirement that every service that uses data protection must call KMS for key management. That helps reduce some of the complexity in cryptography. I think it's probably easier to make a lock than it is to manage and keep keys secure. And so that integration is pretty seamless once you get the pattern of AWS that we'll be talking about around envelope encryption. You can deploy that pattern in over 120 services. Last but not least, in addition to protection, you are likely under any number of city, state, government, regional, multinational, and industry regulations, and compliance standards. Some of those are industry-specific. So if you're managing credit card data, for example, you have to think about the PCI scope. If you're managing healthcare data, you have to think about the scope of HIPAA. And if you're in Europe, you have to think about the scope of GDPR. And if you're in Singapore, you have to think about MAS, and so forth and so forth. So you have mandates and requirements to meet across security compliance controls that data protection can be a tool to help deliver that. Now we're going to jump in a little bit deeper into technical details. When I say lock today, I mean encryption. And by encryption, I mean the transformation of plain text data into ciphertext data. Generally, we use a key for that, and we generally use well-known, well-understood encryption ciphers, also known as algorithms, to achieve that transformation. At AWS, when you're trying to figure out when Jeremy says a lock, or he says, we're going to use a key to open this, or use a key to protect this, we are pretty uniform that our locks are built on AES, which is a government NIST certified encryption method. And there's a mode of AES that we prefer called the Galois counter mode. It gives us some nice properties of AES, like authentication of the encryption operation. And we use a key size pretty uniformly today of 256 bits. That has some nice properties to it. It has some nice protective properties to it, what we would consider to be some post-quantum protection properties to it. And so when I talk about locks today, you should assume it's an AES GCM 256-bit lock as we get going along the way. Of course, you have locks. Locks are opened with keys. How do we protect keys? The answer is we'll use more locks to lock them. Let's jump there next. So if you leave here with only one understanding of locks and keys today, that takes you a little further than where you are. It's an understanding of this pattern called envelope encryption. When I say that 120 services that touch customer data must use data protection, they also all use envelope encryption. Every single one of them follows a very similar pattern, and we're going to jump into that next. You've got data. Data's in plain text. You've got a service that wants to use it. CloudSail, WorkDocs, Secrets Manager, Lambda, CloudTrail, S3, Aurora, RDS, Mongo. It might actually be easier for me to name services that don't use this pattern than services that do. But in all these services, they want to work on manage plain text data, but they want to protect it with encryption. That's their goal. Start with data, bring it into an encrypted state. I've already told you they're all going to use AES. And I've already told you AES uses a data key, or an encryption key, in our case, a 256-bit AES GCM key. And that's how they can lock stuff. But how do they reason about creating those keys, keeping those keys around, securing those keys, making those keys available when they want to open the lock? And that's essentially the role of KMS. KMS is a service that delivers back to all your AWS services two fundamental things. Here's a key, and here's an encrypted version of that key that we're going to protect with a KMS key. And that's what I mean by envelope. KMS will generate a data key and immediately encrypt it with another key in KMS called your KMS key. We have different kinds of KMS keys. Customer managed is our primary type of key. That's a key you create, you own, you set the policies on, and you pay $1 per month per key. We also have AWS-owned keys. Those are keys that are more managed by the services, and you can use those to lock your data as well. And we're going to get into the trade-offs between customer managed and AWS-owned keys shortly. But we're going to create this envelope, and it's going to encrypt the data key. And that envelope is going to get sent back to the service, and the service is going to do two things. It's going to take the data key, use it through AES, and lock data. But it's going to need to be able to open that later, and so it's going to take the ciphertext of that key, also known as a key envelope, and it's going to write that next to the data. And that is it. That's the end of the pattern. If you've got S3 and you're bringing objects to S3 and you use SSE KMS, they're calling KMS to generate a data key. You are naming a KMS key to create the envelope with, and S3 is writing ciphertext of all of your data, and right next to it is ciphertext of the data key. And so later on, when you want to open that cat video in S3, S3 will have ciphertext of the data key, and it'll send it back to KMS and say, go use that key in KMS to give me back my data key. KMS will give back the data key used for this cat video, and S3 will be able to open that data. And the reason I'm spending so much time here is because this exact pattern of envelope encryption is really important to understand because it is sort of uniformly close to 100% of our services that use data protection patterns with KMS use this precise pattern. Now, this is sort of the way you should reason about encrypted data at AWS. All locks at AWS look like this. They are ciphertext used by AES, written next to them an envelope of the key. Of course, for those people paying attention, we now have another key that we have to worry about. If I can get the KMS key, I can open the data keys. If I can open the data keys, I can open all your data in the cloud. So what do we do with a KMS key? I think you might know where this is headed. We encrypt it. We encrypt it with very specialized keys in KMS called domain keys. These keys run only in our HSMs, and they exist only in the memory of that HSM. And so that's how we assure higher levels of security. This is called a key hierarchy, and we're going to cover key hierarchies next. But KMS runs its own key hierarchy. It'll generate data keys. It'll use your KMS root key to envelope the data key, and we'll use our domain keys to envelope your KMS keys. A little bit like a Russian doll. We do some things to rotate those domain keys at some frequency, and so we have a higher level master root key above that in our hierarchy. And that is essentially the steady state of KMS. KMS doesn't keep, the domain keys and the HSM keys in any other place, but we are able to back up your KMS envelope keys to places like S3 to ensure the very highest durability of those. One of the properties of KMS that you have to rely on is we can't forget your key, we can't lose your key, we can't make your key unavailable. If we do anything to lose your key, your ciphertext data in the cloud will be rendered forever unreadable if we can't keep that key. So we spend a lot of work and effort to ensure the highest durability of KMS keys. So those are encrypted by our HSMs and then kept in encrypted formats in places like S3 and in our distributed KMS system. So KMS allows you to create, manage, control cryptographic keys. We spend a lot of time thinking about availability because we need to ensure that our service is always up. We are the first service to have a 5 nines SLA in the data plane. I'm pretty proud of that. We pushed that new SLA last year into the market. We also work very hard to increase the performance of this system over time. We can help customers as they scale out now with auto-scaling of this service. So if you're on a heater and you're sending us 40,000 TPS and your quota is set at 50, our service is now smart enough to auto-adjust your TPS higher with us. Of course, we'll want to work with you, make sure you don't have some misconfiguration that would create some kind of anomalous runaway workload. And we want to coordinate some quota expansion, but we have some very large customers running some very large transactions through KMS globally now. We're in every region that launches, so we're becoming a foundational service of AWS, and we kind of have to be there. If all these services are going to expect us to make locks and keys, we need to be in every region that AWS is in. I mentioned key hierarchies, and I mentioned this key enveloping pattern. Same pattern really everywhere at AWS. So the things I explained about S3 are more or less the same for RDS or Lambda or EBS. All of those will use a data key, and they will use a KMS key to encrypt them. We do have some more advanced options for some customers. We're going to be touching on in a moment. You can replace the KMS fleet of HSMs with your own dedicated HSM. We call that product the Cloud HSM. And we have an interface between KMS to the Cloud HSM called the Custom Key Store that lets you use your own HSM as the top of the hierarchy. And this week, we launched the External Key Store, which is a way to replace the KMS key and the key material in our HSMs with key material in your HSMs in your buildings. So the Custom Key Store can connect to a Cloud HSM, which is still within our data center, or the Custom Key Store can connect to an external HSM, which would be key material kept by you. But coming back into the typical pattern is customers create KMS keys and they protect them in the KMS HSMs. The number one question we get asked is, can AWS operators see our keys? And that's easy to reason about, right? If you're going to bring your secrets to us and you're going to have us be the sort of key custodian for you, you want high assurance that we can't do things with your keys outside of your control. And so we have a lot of investment in controls and capabilities to assure that we can never see your keys. Those keys that I talked about that lock your keys, they only exist in the memory of an HSM. Those HSMs today are certified at FIPS 140 version 2, security level 2, and we eagerly await a review by NIST to bring those HSMs to FIPS 140 version 2, security level 3. We filed that application with NIST in October of last year. Bit of a backlog at NIST right now, but we expect to see that cert come back on our existing fleet of HSMs that will bring us up to FIPS security level 3. FIPS is a certification program, and the FIPS 140 standard is used to certify the security and correctness of HSMs. So for those folks that are more aware of what a FIPS 140 certificate is, it's a government program that tests the security and correctness of your HSM operation. Of course, we do a number of things above the line of a FIPS cert to assure you that these keys are kept secure. There are no human interfaces to these HSMs. There are no ways for us to read or access the keys used in these HSMs. There are no human connections to these HSMs. They're only responding to the KMS API, and you can't change the running state of these HSMs without bringing them offline. There's no configuration changes or code changes to these boxes while they're in production. To move them into an upgrade, you must bring them offline, and at that moment, they will zeroize all of their keys. So a production HSM is the only place to open a key, and the only way to upgrade an HSM is to move it to a zeroized state. We also work with our audit team to run SOC reviews so that the statements I'm making, no AWS operator can see and access a customer managed key, can be validated by third parties that can make attestations of the correctness of what I just said. So some of our customers use a tool at AWS called Artifacts, and you can download in Artifacts our SOC report, and you'll see a series of SOC controls specific to the security correctness of KMS. Moving on. How many keys will you need? It kind of depends on a couple trade-offs between whether you're a centralized organization or a distributed organization, whether you want to tie keys to specific services or share keys across services, or tag keys to projects using tagging. We support tag-based policies and tag-based access control in KMS today. Fundamentally, we recommend tying keys to who owns your data. To us, that is the most logical assignment of how many keys you'll need, because it is the data owner that is the best person in the room to determine what the access policies on that key should be. In general, we have a feature for automatic key rotation, but we also recommend that you skip rotation unless you are required to do so by some compliant or security audit mandate. We talked about this briefly, but let's jump into it with a couple more details. A customer-managed key is a key you own, you pay for monthly, you control the policy on it, you get that full instrumented CloudTrail logging of actions on it, and you could generate that key and replicate it to other regions using the multi-region key feature. The easy button at AWS is AWS-owned keys. These are keys that essentially bring you less headache. It just works. There's no cost to you, but there's also no audit or changes on that key policy. AWS manages and owns that key. We do have a third type of key that you'll see sometimes in our documentation in some of our services. S3 had a lot of customers using AWS managed keys for a number of years. It's kind of a hybrid option in the middle. It's a key created in your account. There are no fees for storing this key, but there are fees for using APIs on that key. You will see CloudTrail activities on that key, but you cannot set the policies of that key. And so AWS Managed is actually being deprecated. So as we go forward and add new services, we'll really be just seeing those two options for you. Fully owned and managed by you, AWS owned and managed by AWS. How do you then control access to your keys? This is a really important question. You know, sometimes people love to geek out on the strength of AES, or if I freeze the silicon and I run lasers on it, can you read the bytes of a key? And then they make a policy that says star.star. And to me, that's frustrating, because like you're going to go to the 20th degree of security on the cryptographic correctness of this key, and you're going to write a policy that's open-ended. Policies are as important as the strength of your keys, because you need the combination of a good key and a good policy to ensure that you get what you want. So we spend a lot of time in this particular part of KMS building out features. We are one of the unique services at AWS that uses both IAM policies so that you can bind actions to your roles for key usage. We have a second authorization engine called the KMS key policies. And it's really the combination of those. You'll write key policies, and you must, and you can optionally write IAM policies to get very specific controls on who can use keys. And what might that look like? We would recommend, in general, a pattern that we call separation of duties. You would write a series of policies for your IT security team. These people don't use keys, but they write key policies. They determine the scope of how a key can be used. And so they would be given roles and rights to write policies, but never rights to read and use keys, because this is a little bit like a fox in a hen house. You want the security control coming from one team and the usage of keys happening in another team. And so we would do that through policies, and the separation into security writes policies, software developers have access to using keys in their flows, and possibly a third role, which is kind of what I consider a read-only role for compliance teams or audit teams to verify the correctness of these deployments. I'm going to finish with one last mention of another HSM service we have, which is the Cloud HSM. This is a more dedicated crypto platform. It has more support for different types of cryptographic algorithms. It has some dedicated client-side tooling for things like PKCS11 and OpenSSL and Nginx TLS integration. And so some customers use this standalone HSM platform as a lift and shift of workloads from where they started in the data center moving into the cloud. And as I mentioned earlier, KMS can use the Cloud HSM as that top of the hierarchy through the custom key store interface. That concludes my grand tour for locks and keys today. I'm going to hand it over to Param to jump into section 2.
Thank you, Jeremy. This was great. So for the second part of our tour today, we're going to talk about certificates and signatures. So every time you use HTTPS over TLS, the first thing that comes is certificates. You would have opened a website like Amazon.com. There is a padlock icon in the browser that tells you that the site is secure, and you can trust it to make sure that it's backed by Amazon.com servers in the back end. So before we dive deeper into the tech side of things, I just wanted to do a primer of what cryptographic signatures are. They are also known as digital signatures. Basically, they make sure that the thing that we are signing, whether it's a file or an identity that it represents with a public key attached to it, is authentic. It's signed by a key, which is, again, valid at the time of signing. And there are two broad categories of signatures that we talk about. First is raw signatures. That's what we looked at in the previous part of the presentation, where there is no identity embedded in the signature itself. And the second type of signatures are certificate-based signatures, where you have the need to tie the identity to a public key so that when you use that certificate, you can know that who is the identity of this certificate attached to this particular file. So there are various ways to use certificates, and we're going to dive deeper into what are the different use cases for these certificates. You would have heard about code signing. You would have heard about certificates especially for IoT devices or containers or service meshes, or the certificates being used for mutual TLS. So what is a certificate? Let's start with that. So certificate is based on public key infrastructure standards, which is based off of asymmetric key cryptography. So unlike symmetric key cryptography, asymmetric key cryptography is based on two key pairs. So these are two separate key pairs, keys, but they are mathematically related to each other. There is a public part of the key, and then there is a private part of the key. So public part of the key is something which is distributed as part of the certificate. And the private key is something that you keep secure, you do not share with anyone. And the other thing is this public key and the certificate combination, they answer few questions. So public key is nothing but a string of bits. And the question it answers is, whose bits are they? What identity they represent? Are these bits valid? What is the time validity associated with these bits? And the validity of the signer who signed this certificate, was it valid at the time of signing? And how do I trust that this certificate actually represents, let's say, example.com? Like, how do we ensure that identity attached to this public key can be trusted? So all of these questions are answered by PKI. So let's look at a sample certificate. And in this certificate, you can see we have various extensions and fields. Serial number at the beginning, that tells the uniqueness of this certificate issued by a CA, certificate authority. And then you can look at the issuer detail. In this case, I picked up an issuer which is a custom OID, custom object identifier. And that we will go into next slides when we talk about Private CA service at AWS that allows you to customize your certificates to the point where you can add custom extensions and custom object identifiers in the certificate itself. So that's the issuer. And then the next part of the certificate talks about the validity. So I just mentioned that how do we know whether this certificate is valid, not expired. So that's the validity that tells you that it's valid till next year. And it followed by the subject. In the certificate, subject is what tells you what is the identity which is being bound to this particular certificate with this public key. And a little bit down below, you will see the actual public key. It's a string of bits which is attached, again, as part of the certificate. It tells you what key algorithm was used. In this case, you can see it's a ECDSA cert. And it follows by, there are a few more X509 extensions. And I'm just going to talk about the key usage one here, mainly. So the key usage one, in this case, say it can sign certificates, it can generate CRLs, and it can do digital signatures. So that means it's a CA certificate, and an extension above it also says basic constraints, critical, and CA is true. So it shows that this is a CA certificate which can sign other certificates using its key pair, and then those certificates can be deployed anywhere you want to use them. So the next question that we usually ask is, okay, so we have a certificate, we have an identity bound to it. What are we going to do with this certificate? So I just want to ask this question from everyone, that how many of you have used certificates and certificate authorities and felt the pain of managing a PKI infrastructure? I know I have. That's amazing. So I guess the gist of certificates is to make sure that your network communications are secure Any data that's traveling over the wire is encrypted and protected. And then again, you can also use the certificates on your mobile devices, on on-prem servers. So the gist is, anywhere you want to protect the network traffic in transit, you have the capability to use certificates with HTTPS over SSL or TLS protocol, and make sure that it's meeting your compliance needs. And because we are hearing a lot of use cases about end-to-end TLS termination in the recent years, where due to compliance reasons or auditing reasons or even your company's security policies require the network traffic to be terminated at the host itself instead of terminating at the load balancer. So at that point, you can deploy the certificates at your host to make sure that the TLS termination is happening at the end, at the last step of the communication. And the key thing here is to identify. And what are we trying to identify here? We are trying to identify a website. It could be a workload. It could be an application. You might be doing a mutual TLS between a client-server kind of workloads where two components need to talk to each other and need to validate each other's identity before the data transmission can start. And that's where the whole story around TLS and SSL handshake comes up, that how the cipher exchange happens and how certificates make sure that the communication can start. And in addition to that, there are a few more use cases. So one use case is to make sure the data non-repudiation, which is a typical use case for code signing of software packages to make sure they are not tampered with. And the last one is more about encrypting data. It could be email encryption. That's like the super simple use case that all of us use with our email servers. So I talked a little bit about code signing. So I just want to ask this question again, that how many of us are using code signing or familiar with the code signing concept? That's nice. So I guess in this case, code signing is the process of signing an executable or a script to make sure that the author's identity is attached to that certificate. And the second part of thing is that file is not tampered with, either maliciously or accidentally. And when it reaches our end customer, it's in pristine condition that it can be trusted and used where it needs to be used. So that's the main question we are answering here with code signing certificates. And traditionally, signatures are a big part of our life. We use driver license signatures. We have home mortgage documents where we do signatures. So the key thing about signatures here is, first, we are trying to identify who is signing. And second part of it is whether the message which is being signed, the integrity of the message which is being signed is authentic, and it is supposed to what it is supposed to be. So in this case, you start with a file or a software package or an application or an executable. And the first step is to make sure that the certificate is generated and signed. And that happens once your build process is done and the package or the library is ready to be shipped. So this is the last step in the software shipment process, where you do the code signing and make sure that the package itself is pristine, and it has all the things that needs to be there. It's authentic and signed by the author, and we also check the identity of the author at the same time. So that's the little code that I added. So if the decrypted hash is not equal to what we were encrypting, that means the package is should not be used. But if it is equal, then it makes sure the package is good to go. So there are a lot of steps that happen when a software is written. So it starts with very simple. We have multiple developers working. They check in that package into a code repo. From there is an automated or a manual build process that makes sure that that package gets built and deployed as part of CI/CD system. And from there onwards, there are various processes that happens. And by the time it's ready for shipment, that's where the signing itself happens. So once the signing happens, the software is ready to be deployed to your customer, which tells that this package is ready to be used. And for the next part of this session, I'm going to talk about different AWS services which are available for all the topics that we talked about. How can we manage certificates? How can we manage certificate authorities? And in the end, how can we generate code signing certificates which can be integrated to your build process? So let's start with the first one. It's AWS Certificate Manager, also called ACM. So the first thing is, there is our public certificates that you can get issued from ACM, which requires DNS validation or domain validation. And then you can issue private certificates through ACM using Private Certificate Authority service. And another type of certificates that you can use with ACM are imported certificates. So you can get your certificates issued somewhere else and bring them and import them back into ACM. And the beauty of that is, at that point, once you have a certificate issued in ACM, there is an ACM ARN associated with that resource. And you can bind that certificate either with a load balancer, so you can have a HTTPS load balancer. And once that certificate is bound, ACM takes care of renewals for you, and the renewals are automated. The updated certificate gets deployed on the load balancer at the time before, so it's about 30% before the certificate gets expired. So it's done with the buffer time to make sure that infrastructure outages do not happen because of certificate expiration. And that's one of the biggest pain points that we have seen. When certificates expire, infrastructures go down. And I talked about public certificates and private certificates on this slide. So I think this might be helpful to talk a little bit deeper about them. So public certificates are issued by managed certificate authorities, which are managed by other organizations. There is a whole CA browser forum, CAP forum, which defines the rules and the compliance guidance for public certificate authorities. The public certificate authorities are pre-installed as part of a trust bundle on your operating system or your browser key store. And you need to do domain validation in order to get a public certificate. So if I want to get a certificate for Amazon.com, I have to prove that I have a domain ownership of Amazon.com before any of the public CAs would issue me a certificate. So in this case, if you go to ACM or AWS Certificate Manager, and you can request a public certificate, that would either be a DNS validated cert or it would be an email validated cert. So once the validation completes, a certificate will be issued, and you will have a certificate ARN, ACM certificate ARN. And at that point, you would be able to take that ARN and bind to other AWS services. And once that happens, if a certificate is bound to other AWS services, at that point, ACM will renew the certificate. And now, so there are certain times where the certificate may not be renewed. One example is email validation. So email validation requires you to click a link in an email so that the domain can be validated. So let's say you get a 13-month cert with ACM. You're at 9-month period, and then 9 months, we try to renew the certificate, and it would generate an email which would go to a mailbox. And then somebody needs to click on that link to make sure that the domain validation is authorized, and at that point, the certificate will be issued. So that adds a manual action in between. So what ACM does is it sends you a notification via either CloudWatch or even bridge notification even, to make sure that if there is an issue with the renewal process or it requires an action from your side, you can go and take that action, and that happens well advanced in time before the certificate expires. And this is just to make sure no infrastructure outages due to certificates. So the second part is the private certificates, which comes from AWS Private Certificate Authority. And in next few slides, we're going to talk more details about that service as well. But just to set the context here, the private certificate is issued by a certificate authority, which is self-managed. So I can have a private CA for my organization. It could be HR, IT, and then I manage the PKI hierarchy for that certificate authority. I may have a root and a subordinate. And that root and subordinate would issue end entity certificate for all the internal certificate needs that I have. And I guess that's where private certificates are useful. They provide much more flexibility on what kind of certificates you can issue, because there is no validation involved with private certificates. And the other thing is, because the trust does not come pre-installed, it's your private certificate authority, you will have to make sure that the trust is managed and installed. And a lot of times it's done by our IT administrators, where they have a PKI hierarchy running, which is internal to a company or an organization. And those CA certificates come pre-installed on our laptops or mobile devices, which are issued by a company. So this is one of the recent launch that we did last month, or this month. So we launched ECDSA support for ACM very recently, and now customers can issue ECDSA certificate. So we allow 2 NIST curves for ECDSA, as you can see, and you can use API, CLI, or CloudFormation to issue ECDSA certificates. So the beauty of ECDSA certificates when compared to RSA certificates, they tend to be faster. So we are doing some performance analysis on our side just to come up with numbers that we can share with everyone. But having the flexibility to use different key algorithms where you may want to use smaller certificates, that's another thing. ECDSA certs are smaller when compared to RSA 2048 or 4096 certs. And when you think about devices where memory might be a big concern, you want every single bit that is saved is a pretty huge saving. So I'm going to talk about ACM best practices that we recommend. The first thing is use DNS validation for certificates. And the main reason is, like I said, the email validation requires a manual effort, which, if a process is not done enough times and it happens once a year, there is a high probability of that process failing when it's not executed enough, or oftentimes. So in this case, once you have a DNS record set up, which is pointing to the token which is given for the first time, ACM will take care of renewing those certificates without requiring any manual action. So we talked about certain cases where renewals may or may not work. And this is one of the cases where we recommend using managed renewals to make sure that DNS token remains and not rely on manual action. But still, there is a need, right? So you may be using an imported certificate because it's needed. And at that point, imported certificate cannot be renewed by ACM. And that's the reason where ACM would send a notification via Event Bridge that can be automated or listened on, and then triggered through Lambda, where you can actually renew that certificate and take a manual action, which is required. So monitor the expiry with the CloudWatch and the Event Bridge that we just talked about. And the last thing is the pinning. So certificate pinning is the process of, it's an online security technique, which is used to make sure that client and server can agree on a certificate which is authorized. And only if that certificate is present, client will make a connection. So this technique was originally employed 2010, 2011. And the main reason for that was to make sure that there is no person in the middle attack, because you know that what is the certificate that you're looking for on that server. So this came up with its own set of problems. So the first one was, if a key compromise happens and you want to rotate a certificate quickly or revoke a certificate, at that point, now you need to go first, update the server, deploy the new certificate, and keep it, the private key there. Secondly, you will have to go and update all of your clients to tell them that don't trust this old certificate because it's key compromised, and look at this new certificate. So that created a friction, and that actually opened up another set of security attacks that could happen. So just to avoid that, we recommend do not use pinning. And if with ACM, because the certificate renewals happen at the 70% of certificates lifetime, the certificates are going to be replaced at some point. And that would break the clients who are relying on a pinned certificate. So if you really have to pin, roots are probably the best thing to pin on. So there are various levels of pinning. You can pin on root, you can pin on subordinate CA, or you can pin on end entity certificate CA. So even subordinates are not recommended for pinning because of various reasons. We may have to rotate the subordinate. It could be a legal reason. It could be a compliance reason. And once that subordinate rotates, again, that would break clients. Roots, on the other side, require a whole campaign when a root rotation happens. So it's more logical to pin on root if it is really needed. So that was all ACM. So the next one is AWS Private CA. So Private Certificate Authority Service is a service which allows you to manage certificate authorities centrally in one single place. And it allows you to customize private certificates for different needs. Those certificates can be used for devices, Kubernetes, service meshes, or simple SSL, TLS communication in the internal network. The other good thing here is it provides developer agility, and that means that there are CloudFormation support, API, SDK, CLIs available to automate the generation of private certificates. And you can use those certificates to deploy either with AWS through ACM, or you can deploy these certificates on prem servers where they might be needed for internal communication over a private network. And we already talked about the customization to meet certain needs. One really good example of customization is, let's say there is an IoT device, and you want to use those certificates to communicate in home network for those IoT devices. So one possibility to customize the certificate is to have a device ID and a network ID and that certificate itself, so that when that mutual TLS connection happens between the devices in a home network, we know they are secure. So the next critical thing here is the auditing side of things. So Private CA allows audit reports where you can see all the certificates which are ever issued by this CA in one single place. And that can be used to do, so you can set up an auditor, for example. You can see that in last 24 hours, I expect only 10 certificates to be issued. Let me see my side of world with what PCA has with the audit report check. So you can write that auditor and make sure that they are in sync. And the second way to audit is CloudTrail logs. And CloudTrail logs, and I can share here in the next slide where I had a nicer diagram. So CloudTrail logs provide you the auditing every time the key pair is used, whether it's used for CRLs, which is certificate revocation list, or OCSP, which is another mechanism to revoke certificates if there is a key compromise or there is a need to revoke a certificate. So in this case, you can see that Private CA can be used with either SDK CLI for full automation, and it's connected with ACM, so you can issue private certificates through ACM, and that gives you the capability of renewals. So now you don't need to worry about renewing your private certs, and there is an API in ACM which is export certificate, which allows you to export your private certificates on-prem, on EC2 machines, wherever those certificates are needed. So once the certificate is exported from ACM, it's treated as in-use. So in-use certificates are auto-renewed, and there will be a notification sent to that account that this certificate is auto-renewed and ready to be used. And there are a few other use cases of private certificates where either you want to use those certificates for banking purposes, or you want to use those certificates for devices, which we already talked about, or service meshes. So the next question is, okay, we have public certificates and we have private certificates. So when do we use a private CA? And we a little bit touched upon when you want to implement end-to-end encryption to AWS resources or on-prem servers. That's one really good use case. And this is becoming popular because of compliance reasons or need to terminate traffic at the end host, whether it's EC2 machine or an on-prem host. And the other thing is there is a support for Kubernetes with Private CA. There is a plugin called Private CA Kubernetes plugin, which is used to link Cert Manager, which is another open source tool, and this plugin, which is again open source. And these two can deploy together on your Kubernetes host or pods, and it generates certificates automatically. If you're familiar, there is a YAML file that you can create which can set up the issuer, and then that issuer is automatically used to issue certificates from PCA, and Cert Manager takes care of the renewal of certificates on Kubernetes. And then there are various places you can terminate TLS in Kubernetes. It's load balancers, or it's your ingress controller, or even at end host. Or you can also do mutual TLS between pod-to-pod communication. So that's one use case. The other thing is binding the identity to public key. That's how we started. So there are times when you want to create a certificate which is bound to an identity. And one simple example could be you want to issue a certificate where subject is employee ID, because there are laptops which are coming up in the network, and there is a certificate which is presented that tells from which laptop this request came in. So that's another place. So we talked a little bit about the customization of the private certificates, and we touched on how subjects can be customized. So there are a few more customizations which are allowed. You can issue certificates with custom validity. It can be hours, days, months, or years, or even a given time. And the other key thing is there can be custom extensions. So I can go ahead and add my foobar extension in my certificate, which is probably very specific to my software. And it understands what kind of verification and validation needs to happen if foobar is present. And we have seen those use cases with banking applications or even IoT device applications. There is an upcoming standard for device-to-device communication, which is known as Matter. And that standard is, there are multiple organizations and companies coming together to create a standard on how different devices would communicate with each other. And as part of that standard, there are few extensions which are custom object identifiers, which are not normally seen in end entity certificates. So that's another place where certificate customization really helps to meet a niche market. And then there are recent integrations that we have done. So if you have heard about IAM roles anywhere, where IAM roles can be used on-prem, it requires a trust anchor, which can be a AWS Private CA, and that can be used to make sure you can get credentials from IAM on your on-prem workloads. So let's segue into AWS Signer. That's another AWS service which is mainly for providing code signing capabilities. And the good thing about AWS Signer is you can integrate the AWS Signer APIs in your build process, so that as part of your CI/CD whole system, the build system, once the software is ready to be released, it comes out with the code signing certificate attached. So the goal of AWS Signer is to make code signing very simple and easy to use, that it works out of the box. And I guess the next slide is actually going to talk about the use cases, how it's done, how it's made easier. So the one big example is the Lambda. So code signing is integrated with Lambda, where Lambda takes care of verifying that, yes, the certificate is valid, not expired, not revoked. And once that validation and verification happen, at that point, that Lambda code is ready to be used. And the good thing about this one is it does not add any latency latency-sensitive Lambda operations. So what does that mean is the checking is happening at the deployment time, not at the runtime. The second part of the code signing use case that we have and we have seen is with IoT, AWS IoT, which is supported through ACM, where you can import a code signing certificate into ACM and use it with IoT, like free RTOS and other different techniques. So we are almost at the end. So we talked about AWS Certificate Manager, how it can be used to centrally manage certificates. We talked about, just a refresher, public, private, and imported certificates. And then the renewal is probably the big one, where it allows you to renew certificates or publishes a notification when a certificate is renewed and ready to be consumed by the workloads. Then we talked about private CA, which can be used to manage certificate authorities centrally, especially for a PKI admin, where a CA is created in one account, and that can be shared with multiple other accounts, and multiple other accounts can actually request end entity certificates. So this is the central management of certificate authorities. And then in the end, we talked about AWS Signer and signatures and how code signing is being used with Lambda and IoT. So thank you so much for joining us today. This was good.